Alright, in this video here we're going to talk about graphs of functions, vertical stretching and shrinking. Alright, so this is one of the rules for transformations of graphs, and if you haven't seen the other videos I've done on transformations of graphs, you should check those out. There are a whole bunch of different rules. This video is just going to focus on the rules for the stretching and shrinking in the vertical direction. Alright, so how we end up with a graph that gets stretched or shrunk in the vertical direction is by multiplying our parent function by some constant, some number. Right? So if I'm graphing y equals c times f of x, well, whether we get a stretch or a shrink depends on what number that is, or the value of that number. If that number that we're multiplying, c, is greater than 1, right? So if it's a number bigger than 1, that's going to stretch the graph of y equals f of x vertically by a factor of c. All right, so basically what that means, and if you watch some of the other videos that I did about the other rules for transformations, it's a common theme in all these different rules, is that when something happens outside of the parent function, it's affecting the y coordinates of the graph, right? So what's happening here is when I'm multiplying by a number bigger than 1, I'm literally multiplying all of the y coordinates of my graph of my parent function by that number c. Right, so let's say c is 2, and I'm graphing 2 times f of x. Well, if each of my y coordinates gets multiplied by 2, right, that's going to stretch out the graph, right? Each one is getting bigger by a factor of 2, so all the y coordinates get multiplied by 2, and it stretches the graph out in that vertical direction, because everything is now twice as tall as what it was before. Right? If I multiply it by 3, now everything is 3 times as tall as it was before, and it stretches the graph out even further. All right. Remember that y equals f of x, that's what we call a parent function. There are certain parent functions that you should know what they are, and you should know what the graphs look like. And I did a video just on parent functions, so if you haven't seen that, please check it out. Like the quadratic function, the cubic function, the square root, the absolute value function. Those are some of the parent functions that you should be aware of. Right? So you should know what that graph looks like, and then if you have that same function but it's being multiplied by a number, again, if that number is bigger than 1, it's going to take that graph of the parent function that you know and stretch everything out, right? You're literally multiplying each y coordinate by that number c, right? So that's how we get a vertical stretch, is when we multiply by a number bigger than 1. Well, if our number is less than 1, if 0 is less than c is less than 1, right? So if c is 1/2 or 0.2 or something like that, right? Some number that's in between 0 and 1, that's going to shrink the graph of y equals f of x vertically by a factor of c, right? So the rules here are the same, right? What's going on is, whatever number is multiplying outside that function, we're going to multiply all the y coordinates of our parent function by that number. If that number is bigger than 1, well, when you multiply by a number bigger than 1, the numbers get bigger, and that's going to stretch out the graph in that vertical direction. But if you multiply by a number that's less than 1, a number in between 0 and 1, well, that makes numbers get smaller. Right? If I multiply all my y coordinates by 1/2, like say this hand is the x-axis, and this is like my y coordinate. Well, if I multiply it by 1/2, it gets smaller, right? It's half as tall as what it was before, right? So if my number that I'm multiplying is in between 0 and 1, I'm shrinking the graph, right? All my y coordinates get multiplied by that fraction or that decimal number, and they all get shrunken down, all right? So that's what we have going on for vertical stretching and shrinking. Again, it's the same basic rule. It's just whether that number is bigger than 1 or less than 1 determines whether the graph is going to stretch out or whether it's going to shrink. But if you just remember what the rule says, or why the rule is what it is, right? We're multiplying outside of the parent function, so every one of my y coordinates gets multiplied by whatever that number is. And then just whatever happens, happens. If I'm multiplying by 5, yeah, everything gets stretched out by a factor of 5. If I'm multiplying by 1/3, everything gets shrunken down by a factor of 1/3. All right, so that's our basic rule for vertical stretching and shrinking. And what I'm going to do now is pause the recording and do some examples where we actually graph some parent functions and do these different transformations of stretching and shrinking in that vertical direction. One thing I just thought of, I just erased the board and I was about to put up the examples, and I thought of something that I forgot to mention. The things like if c was greater than 1, it stretches the graph. If c was in between 0 and 1, then it shrinks the graph. Well, what if c is a negative number? Like, what if I multiply my parent function by a -3? Well, that really combines two transformations, right? Multiplying it by 3 is going to stretch it out by a factor of 3. And if you watch the video I did on the reflections, that negative in front of the parent function flips the whole thing over. Right, so if you multiply by a negative number, it either stretches or shrinks depending on whether that number is bigger or less than 1, but that negative also flips the graph over in that vertical direction, right? So that's what happens when you get multiplying by a negative. I just wanted to point that out because it says C is greater than 1, C is in between 0 and 1, so you might be thinking, well, what if it's less than 0? What if it's a negative number? That flips the graph over. That's that reflection. All right, I'm going to pause it again and actually put up the example now. All right, a couple examples up here now. We've got the first one, g of x equals 2x squared. The second one, h of x equals 1/2 x squared. All right, so anytime you're graphing a function that involves doing a transformation of a graph, first thing you always have to do is identify what the parent function is. Well, for both of these, they both involve an x being raised to the second power, which means my parent function is going to be the quadratic function y equals x squared. All right, so, and like I've said before, I think earlier in this video, if you haven't seen the video that I did on parent functions, you should check that out because that tells you which parent functions you should know and also what the graphs of those look like and some of the key points on those graphs. So if you're not familiar with those, you should check those out. All right, so both of them involve an x squared, so my parent function is y equals x squared. So now, that's the first thing, identify the parent function. Next thing, what does the graph of that parent function look like? All right, well, y equals x squared. Again, you should just have a mental image of what that graph looks like. You should also know the coordinates of some of the points on that graph. Right, so for y equals x squared, some of my coordinates are 0, 0. I got the point up here 1, 1, and I have the point 2, 4. All right, so those are some of my points, and then I have on this side negative 1, 1, and I have negative 2, 4. I missed that point a little bit, but close enough. All right, so those are some of my key points, and now I can connect the dots here to sketch that graph. All right, so that's my graph of the parent function y equals x squared. All right, so that's what y equals x squared looks like. We got that, and again, you should just know that, and you should just know the coordinates of some of these points in order to be able to graph these transformations correctly. All right, so that's my graph of y equals x squared. Next thing, I have to identify, well, what is the transformation that I'm applying now when I try to graph 2x squared? All right, so that's where knowing the rules, all the different rules for transformations comes into play. All right, so 2 times x squared, right? I'm multiplying by 2. That 2 is outside of the parent function, right? If it was inside the parent function, it would look like this. If it was like 2x in parentheses squared, now that multiplying by 2 is inside the parent function, and that's a different rule, right? When that 2 is directly attached to the x like that, and both the 2 and the x are being squared, that's not the rule we're talking about here. That's actually going to be a horizontal stretch or shrink. Right, so we'll talk about those types of things in another video. I just wanted to point that out to you. That's what it looks like when that multiplying by 2 is inside the parent function. Here, the 2 is outside of the parent function, right? The x squared is here. Only the x is being squared. The 2 is not being squared. So that means the 2 is not part of the quadratic function here. It's separate from the x squared. It's just multiplying it. Right, so since that 2 is outside of the parent function, that's going to be our vertical stretch and shrink. Right? When we multiply by a number, when we multiply our parent function by a number, it either stretches or shrinks the graph vertically. And since our number is bigger than 1, it's going to stretch out the graph, right? All of my y coordinates are going to get multiplied by 2, which is going to make each one taller and stretch the graph out. All right, so that's our next thing, is to identify that when we multiply our parent function by 2, that's going to be a vertical stretch. Right? If that number is bigger than 1 that we're multiplying, it stretches out the graph. All right, so now what I do is I go to my graph of my parent function, and every one of my y coordinates I multiply by whatever number is out there. Right? If this blue graph is y equals x squared, well, 2 times x squared, I'm taking all those y coordinates and multiplying each one times 2. Right? Literally, that's what this is doing. It's multiplying everything times 2. Right? But just the y coordinates. All right, so 0, 0. Well, if I do 0 times 2, that's still 0, so that point is still there. The point 1, 1, if I multiply my y coordinate 1 times 2, I get the point 1, 2. Right? The point 2, 4, if I multiply my y coordinate 4 times 2, I get 8. All right, so now I have the point up here, 2, 8. And on the other side, the same thing happens. Right? On this side, I'm going to get negative 1, 2, and over here, I'm going to have, and this is kind of in the way of what I wrote up here, but that's going to be the point negative 2, 8. Right? And if I connect my dots there, I get the graph of y equals 2x squared. Right? And as you can see, that stretches out the graph. Right? The y equals x squared, the blue parabola, was a nice smooth parabola, 2x squared is a steeper parabola. Like the walls get steeper because it's stretching it out in that vertical direction. Right? It's taking every single one of those points and making it twice as tall as what it was before, so the graph gets skinnier and steeper as it rises. Right? So that's what happens with a vertical stretch when we multiply our parent function by a number that's bigger than 1. Right? And remember, things that happen outside of the parent function affect the vertical direction, they affect the y-coordinates. Things that happen inside the parent function affect the horizontal direction, they affect the x-coordinates. That's one of the basic rules of doing the transformations of graph. Right? Outside is the y, inside is the x. Right? So if I'm multiplying outside, I'm multiplying all my y-coordinates by 2. All right? For the next one, 1/2 x squared, right? H of x equals 1/2 x squared. Right? Same parent function, right, is still an x squared. I'm still multiplying that by a number that's outside of the parent function. So it's once again going to be a vertical stretch or shrink. But since my number now is less than 1, that's going to be a vertical shrink. Right? I'm going to multiply all my y-coordinates of my blue parent function here. All those y-coordinates get multiplied by 1/2. That makes each one shorter than what it was before, and it makes that whole graph kind of shrink down lower. Right? So first point, 0, 0. If I do 0 times 1/2, that's still 0. So this point is still here on the origin. The point 1, 1, if I multiply my y-coordinate 1 times 1/2, that's going to be the point now 1, 1/2. Right? The point 2, 4, if I multiply 4 times 1/2, that gives me 2. Right? So I get the point over here, 2, 2. Right? So again, every single y-coordinate, I'm multiplying by whatever number is in front of that x squared. When that number is bigger than 1, it makes all the points higher. When that number is less than 1, it makes all the points lower. Right? That just naturally is what's going to happen when you multiply by either a number bigger than 1 or a number less than 1. Same idea on the other side. Right? For negative 1, 1, that becomes negative 1, 1/2. For negative 2, 4, when I multiply the 4 times 1/2, that's going to become negative 2, 2. All right, now if I connect all those points, we see that we get a different kind of shape. Right, here's the graph of y equals 1/2 x squared. Right, the parabola gets flattened out. Right, it gets shrunk down lower. All right, so that's the nature of having vertical stretches and vertical shrinks. Right, notice if you've watched some of the other videos that I've done on some of the other types of transformations, a lot of times the shape of the graph is the same. Like if you're doing a horizontal shift or a vertical shift, you're taking the exact same shape and just moving it left or right or up or down. Or if you're flipping it over, it still has the same shape, just going in the other direction. So that happens with some of the transformations, but when you start doing vertical stretching and shrinking, it actually changes the shape of the graph. Right, the graph of y equals 2x squared does not have the exact same shape as the graph of y equals x squared, or the graph of 1/2 x squared. Right, they all have slightly different shapes. They're all parabolas still. It's just that the walls of the parabola get steeper or flatter depending on what number you're multiplying by. Right, the higher that number is in front of the x squared, the skinnier and steeper the walls of the parabola get. Right, the smaller that number is, the more wide and flat the walls of the parabola get. All right, so that's vertical stretching and shrinking. A number outside of the parent function that's multiplying the parent function, you literally multiply all the y-coordinates on the graph of your parent function by whatever that number is. If it's bigger than 1, it stretches it out. If it's less than 1, it shrinks it down. Make sure you check out my other videos on the other rules of transformations. There are quite a few of them, and you really need to know all of them because sometimes they get mixed together in the same problem.